So what the problem statement also asks in two parts is part A to draw 6 free-body diagrams for each of the members and the hydraulic cylinders themselves. And part B is if each of the 3 hydraulic cylinders is capable of producing 1,000-pound force in both tension and compression, depending on the loading conditions, of course, determine the largest weight W that can be supported in the position shown. So really, your textbook sees this, and quite naturally, as an extension of all the static analysis problems that you've done for rigid bodies in 2 dimensions. And given the fact that you have a bunch of linkages connected at joints, it also extends the whole idea of trusses and how you may analyze truss structures with the method of joints and so on. What's special about this problem is the inclusion of 3 hydraulic cylinders, GF, EC, and BC. So when you encounter hydraulic cylinders and are to draw free body diagrams for these, what you really need to do is replace these hydraulic cylinders by tensile or compressive forces alone, depending on the loading conditions, and that generally is a very good place to start. So I will generally start with the hydraulic cylinders, and I find that since the load or the weight W is acting downwards into the tub, the hydraulic cylinders themselves are in tension. They are pretty much being pulled upon because of the load W. So since the hydraulic cylinders are in tension, I am going to draw tensile forces at all the joints associated with these hydraulic cylinders. So I've got, let's see, tensile force F sub GF over here, and an equal and opposite tensile force which is FGF again. The other forces are FEC and FEC. We've also got FBC, which is tensile again, and FCB. So that's a bunch of tensile forces that you could include on your system of hydraulic cylinders. Now mind you, some of these linkages are connected through hinge pins and also connected to other linkages through pins. So you would want to replace these by associated reaction forces as well. So the reaction forces that we may consider are so. I will first start with joint D, which has a hinge at it. Since it's a hinge pin, we've got 2 reaction forces, one horizontal and the other vertical. So we've got D sub X and D sub Y acting at hinge pin D. Now mind you, even though the hydraulic cylinder GF is connected to a hinge pin at G, the idea of a hydraulic cylinder is irrespective of the kinds of support that it has, it is always in tension or compression, so really forces along the axis alone. So that's one. Let's see what's next. So point F is a pin, and hence it's going to have vertical and horizontal reactions, which we shall call F sub X and F sub Y.